subscribe. Click on the bell. Like, comment, share.
Observe the video. Half of an Alka-Seltzer tablet is dropped into a test tube filled with water. The tablet starts to dissolve and releases carbon dioxide gas. A cork stopper is immediately inserted at the end of the test tube. As more carbon dioxide gas is produced, the pressure in the test tube starts to build up. Observe what happens when we increase the pressure by pressing the cork stopper. Why does the reaction stop when there is high pressure in the test tube? Now, observe what happens when we loosen the stopper. Why does the reaction is able to start again when the pressure in the test tube is released?
We do not usually talk about the concentration of gases. It is more common to refer to their pressure. If we have 100 cubic centimeter of gas in a graduated syringe and press the plunger down from 100 cubic centimeter mark to the 80 cubic centimeter mark, we have increased the pressure of the gas. In other words, we have increased its concentration since the number of the gas particles is the same, but in a smaller volume. Click each of the syringe and observe the animation of the reaction of gas molecules. Click syringe A. Now, click syringe B. In which syringe will the mixture of gases react faster? From your observation, what can you conclude? When the same number of reactant particles is in a smaller volume, there are more chances for collisions between the reactants to form more products. Now, based on the activity that we have just done, design an experiment to investigate the reaction rate of a chemical reaction involving gas at different pressures. Use these materials and apparatus to design your experiment. Let's look at examples of chemical reactions that are affected by pressure. First, let's have a look at car engines. A car engine converts the energy of the burning petrol or diesel into motion so that a car can move. A petrol engine takes a mixture of vaporized petrol and air, compresses it, and ignites the mixture with a spark. The gases expand, and this results in a power output. A petrol engine compresses at a ratio of 8:1 to 12:1. A diesel engine, on the other hand, takes in just air, compresses the air to high pressure and temperature above the ignition temperature of the fuel. The fuel is then injected into the compressed air, resulting in the expansion of the gases and power output. A diesel engine compresses at a ratio of 14:1 to 25:1. Many trucks and heavy equipment use diesel engines instead of petrol engines because diesel engines start easier as compared to petrol engines. The high compression of gases in a diesel engine means that they don't need an ignition system, unlike petrol engines. Because of this, diesel engines start easier than petrol engines. Answer the question by choosing your answer from the drop-down list. The production of margarine is one of the reactions that are affected by pressure. It can be produced from reaction of natural oil such as palm oil with hydrogen gas at 102 atmospheres. This reaction is called hydrogenation. Can you predict what would happen if we increase the pressure of hydrogen gas? The conversion of oil into margarine is faster at a higher pressure. The Haber process is the reaction of nitrogen and hydrogen to produce ammonia. The reaction is carried out under conditions of 250 atmospheres at 450 to 500 degrees Celsius and using iron as catalyst. Do you think pressure affects the rate of ammonia production? What do you think would happen if the pressure is increased in this reaction? We now know that the rate of reaction of gases is greater at higher pressure. How can an increase in pressure increase the rate of reaction? Let's look at what actually happens at the molecule level. Drag the slider to 1 atmosphere and observe what happens. Then, increase the pressure to 10 atmospheres to see the difference. At low pressure, particles are far apart, which means that fewer collisions take place. This slows down the formation rate of the products, thus decreasing the rate of reaction. At higher pressure, particles are closer to each other, resulting in more chances of collisions. This increases the formation rate of the products, thus increasing the rate of reaction. High pressure is a factor that is commonly used in the industrial processes to make reactions go faster. Pressure changes will only affect the rate of reaction where gases are involved.
In this lesson, you have learnt about the effect of pressure on the rate of reaction. Click each button to review the key points. We have learnt that pressure affects the rate of a chemical reaction involving gas. The higher the pressure, the higher the rate of reaction. Examples of chemical reactions that are affected by pressure are chemical reaction of gases in a diesel engine, hydrogenation process to produce margarine, and Haber process to produce ammonia. When the pressure is low, molecules are far apart. Chances of particles colliding is less. It will decrease the rate of reaction. When the pressure is high, the molecules are closer to each other. Chances of particles colliding is more. As a result, the rate of reaction increases.
Thanks for watching. Don't forget to like the video. And don't forget to subscribe.